This is the solution key for Unit 3 Practice Exam A. So for question 1, first need to evaluate the tangent of negative pi fourths. Tangent of negative pi fourths is equal to negative 1. And then evaluate the inverse sine of negative 1. And that's at negative pi halves. See, the thing to remember here, negative 1 as a y value on the unit circle is in between quadrants 3 and 4. How we've typically read the unit circle there is 3 pi halves. But if you recall, the way that inverse sine is defined as a function is between negative pi halves to pi halves. So instead of 3 pi halves, we're going to call it negative pi halves. Okay, question 2, find the measure of the missing angle here. So this is going to use inverse trigonometry. So here we have the hypotenuse and we have the opposite length. So that's going to be sine. So the sine of theta is equal to 11/13, which means theta is equal to the inverse sine of 11/13, which is approximately 57.8 degrees. Question 3, we're solving an equation, and the argument is how we described it in class. The argument here is theta, the argument here is 2 theta. So it's best if we can have equations where inside the trig function it's the same argument. So I'm going to use a trigonometric identity to change cosine of 2 theta. So I'm going to change cosine of 2 theta into 2 cosine squared theta minus 1. And then if I get one side equal to 0 by subtracting cosine squared on both sides, then add 1, and then square root. So now solving 2 different equations, cosine theta equals 1, cosine theta equals negative 1. So cosine theta equals 1 happens at 0 radians. Cosine theta equals negative 1 happens at pi radians. Okay, question 4. I'm going to divide by 4. Then square root both sides. And then again, solve 2 equations here. Sine theta equals 1/2. Sine theta equals negative 1/2. Sine is equal to 1/2 at pi over 6. Now, technically I should have done it here as well. The general solutions are, for example, pi over 6 plus 2 pi k. Remember, that's what we talked about in class. However, since we're restricted and we want the solutions to be between 0 and 2 pi, if I add 2 pi onto pi 6 or add 2 pi onto 0 or pi, we're going to be outside of that interval. So I'm going to skip the general solutions and just write the particular solutions that are in that interval. This also occurs when theta is equal to 5 pi over 6. Now, sine theta equals negative 1/2. This occurs in quadrants 3 and 4. So this happens when theta is 7 pi over 6 and when theta is 11 pi over 6. And again, I'm not using the general solutions of plus 2 pi k on either of these because we would be outside that interval 0 to 2 pi. Okay, question 5. Find the measure of angle F. So there's a missing angle there. The information given is we have an angle here and a side and a side. So this is side angle. This is that ambiguous case of the law of sines. So I'm going to set up the proportion, two equal ratios of law of sines. So we need one of the ratios has to have a side and the angle across from it. So starting with that one, we have sine of 123 degrees is equal to 44 miles. And then on the other side it can be the sine of the unknown angle. And then including that, we have to have the side across from it. So simplifying this quantity is 0.438. Inverse sine on both sides gives us approximately the angle measure of 26 degrees. Okay, so for question 6, we're finding the measure of angle C. And the given information is side, 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 so this is law of cosines. So if I'm trying to find the missing angle here, then I'm going to begin the law of cosines formula with the side across from it, so 17 squared. And again, move these two quantities first, so subtract and then divide by those. And then change this into a quantity. It's 0.826. And then inverse cosine on both sides to get roughly 34.3 degrees. So in a question like number 7, sometimes it's helpful to draw just some random triangle, Q, R, P, and it obviously won't be to scale. Here, measure of angle Q is 113.5. If this is angle R, then side R is the one across from it, so this would be 15.4. If this is angle P, then side P would be the one across from it, 25.1. To solve the triangle means that you find all the missing pieces. So we need the measure of angle R, the measure of angle P, and the side length here of Q. So we have side, angle, side. So this is a law of cosines to start with. So if I want to find side Q, then this would be law of cosine. So Q squared is what I'm going to begin with because it's opposite of the angle given. And from this, we get Q is 34.3 kilometers. So now we need to find either the angle R or angle P using either law of sines or law of cosine. So if we wanted to find angle P here, for example, then I would do another law of cosines. So if I want to find angle P, I'm going to start this with the side across from it for law of cosines. So this is angle P right here. Then just need to subtract, divide over here, turn this into a quantity, and then use inverse cosine. So subtracting the 15.4 and the 34.3 squared and then dividing by -2, 15.4 times 34.3, that gets 0.7417. So inverse cosine of that gives us a value for P in radians, or sorry, in degrees rather, of 42.1 degrees. And now we can use that if we have two angles of a triangle, we can find the third angle. So angle R is 24.4. So we have measure of angle P, measure of angle R, and the length of side Q right there. Okay, for question 8 and question 9, we find the area of a triangle. There were two formulas given to find the area of a triangle. One of them is if you have all three sides. There was a formula that works well for that. There's a different formula if you have side angle side. So what I'm going to do is find a missing side here. I'm going to find this missing side x. And since we have angle side, this is law of sines. And this angle right here, if you add these two angles and divide by, or subtract that from 180, we get 16 degrees. So this angle right here is 16 degrees. So I'm going to use that angle because it's across from this side I'm trying to find. So, and now I need one of these, this second ratio to be known quantities in the numerator. So I need a length plus an angle across from it. So I have 4 and then the angle across from it. So I'm going to use that side length of 4 and then the sine 136 degrees. This will give me the value of x. So I'm getting this side length of x equals 1.59. So now I have a side angle side. So then the area is 1/2 of the two given sides, the product of the two given sides, times the sine of the angle between them. And that comes out as about 1.5 square miles. Now for question 9, I'm going to use a different formula. So this formula, when you have all three sides, side, The first quantity you need is called S. It's the semi-perimeter. That's half of the perimeter. So if we take and add all three side lengths, divided by 2, we get 16 1/4. So then the area follows this formula. So it's basically the semi-perimeter, and then you form 3 more products of the semi-perimeter, subtract each one of the 3 side lengths, and then you square root. And from this, I'm getting roughly 28 square miles. Okay. Question number 10. We've got 2 people, Michael and Brenda. They're 2 miles apart. Michael spots a UFO hovering over a spot on the runway directly between him and Brenda. He records the angle of inclination from the ground to the craft to be 75 degrees. So we have some UFO here. He's looking up. That's a 75-degree angle. Brenda is radioed, and she sees that the angle of inclination from her position is 50 degrees. So this is 75 degrees. This is 50 degrees. How high off the ground is the UFO at this point? To the nearest foot. So what they're asking is, what's this height right there? So the triangle between Michael and Brenda and the UFO is an angle side angle. So this is a law of sines, and what we can do is either find this length here or this length here and then separate it into a right triangle. For example, if I want to find this missing length x, so I can use law of sines here. So this length is across from that angle. So that's going to be x over the sine of 75 degrees. And then the other ratio of the law of sines has to have a complete numerator. We have to know the side length, and we have to know the angle across from it. So the only side length we know is 2 miles. So we need to know this angle right here. So if we add these two, 75 plus 50, subtract from 180, that'll give us that angle. So it's 55 degrees. So then, continuing the law of sines, so solving this gives us x equals 2.358. So now if we separate this triangle, this is still a 50-degree angle. This is 2.358. So this is Brenda over here, and then this is the UFO, and this is a right angle. What we're trying to find is this length here now. I'm going to use a different variable. Let's use y, since we already used x. So if we want to use the sine of 50 degrees is equal to the opposite length y divided by the hypotenuse. Then we can find the value of y as 1.8 miles. But it wants the answer to be to the nearest foot. So now we need to convert 1.8 miles into feet. So 1.8 miles. We can use a conversion factor here. We want miles in the bottom. So 1 mile is 5,280 feet. So now miles will cancel, and this will give us the answer to the nearest foot, which is 9,504 feet above the ground.